For most of human history, wealth was physical. Land, factories, ships, oil, buildings, machines. The most powerful economic actors controlled tangible assets. Then the economy became digital. The assets changed. Data became valuable. Software became infrastructure. Platforms became marketplaces. And code began to perform functions once controlled by people. But something even more important happened. Algorithms began to make decisions. What appears on a screen, which product is recommended, which advertisement is displayed, which loan is approved, which transaction is flagged, which trade is executed, which company receives capital, and which business disappears from view. The algorithm is no longer simply calculating. It is allocating attention, opportunity, risk, capital, and access. This changes the architecture of wealth, because whoever controls the system that makes decisions may influence where value flows. The modern economy does not operate only through prices. It operates through algorithms. And algorithms can process information at a scale no human organization can match. They can analyze millions of signals, execute decisions in milliseconds, and continuously adjust to changing conditions. This creates a new economic advantage, the ability to make more decisions faster, at greater scale, with less human intervention. The result is a world where wealth increasingly follows computation. And when computation becomes a source of economic power, the owners of the algorithms begin to matter more than the algorithms themselves.
An algorithm is often described as a set of instructions, a process, a calculation, a formula. But in the modern economy, algorithms are becoming decision engines. They determine what to show, what to prioritize, what to recommend, what to approve, what to reject, and what to optimize. A traditional business may have thousands of employees making decisions. An algorithm can make millions. A human manager may evaluate a few dozen variables. A computational system can evaluate millions. A human may work during business hours. An algorithm can operate continuously. This creates a difference in scale. The system can observe more, calculate more, and act faster. The decision layer becomes embedded inside the economy. A customer searches for a product. An algorithm determines the ranking. A company applies for financing. An algorithm evaluates the risk. An investor enters the market. An algorithm executes the trade. A business launches an advertisement. An algorithm determines who sees it. A worker applies for a job. An algorithm may filter the application. The decision is often invisible. The user sees the result. The system sees the calculation. This creates a new form of economic power, the power to shape outcomes without directly owning the outcome. An algorithm may not own the customer, but it may decide which customer sees which product. It may not own the company, but it may determine which company receives attention. It may not own the market, but it may influence how capital moves through it. This is why algorithms matter. They are becoming the invisible decision layer of the global economy.
Algorithms are only as powerful as the systems around them, and one of the most important inputs is data. Every transaction creates information. Every search creates information. Every click creates information. Every movement through a digital platform creates information. The data reveals patterns, preferences, demand, risk, behavior, and probability. The more data a system collects, the more it can potentially learn. The more it learns, the better its predictions may become. And the better its predictions, the more users may rely on the system. This creates a feedback loop.
More users create more data. More data improves the system. A better system attracts more users. More users create more data, and the cycle accelerates. This is one of the most powerful forms of digital concentration. The advantage is not always linear. A company with twice as much data does not necessarily have twice the advantage. It may have a better model, a better prediction system, a better product, more users, more data, and even more advantage. This is data compounding. But data alone is not enough. The company also needs the infrastructure to process it, the compute power, the storage, the algorithms, the talent, and the distribution network. This creates a stack. Data at the bottom, compute above it, algorithms above compute, and economic decisions at the top. The companies that control more layers may create stronger advantages. And when the system becomes better at predicting behavior, it may become better at influencing behavior. This is where prediction becomes power. The modern economy competes for attention. Every screen is a marketplace. Every notification is a request. Every recommendation is a decision. There is more content than any individual can consume, more products than anyone can evaluate, more information than any human can process. So algorithms filter, they rank, they prioritize, they decide what appears first and what disappears. This creates a new economic function. The algorithm becomes the gatekeeper of visibility. A business can exist, but if nobody sees it, it may as well not exist. A creator can produce, but if the system does not recommend the content, the audience may never arrive. A product can be available, but if the ranking system places it at the bottom, the market may never discover it. Visibility becomes an economic asset, and the algorithm controls visibility. This creates enormous power. The system does not need to own every product. It only needs to influence which products receive attention. It does not need to control every creator. It only needs to influence distribution. The platform becomes a market. The algorithm becomes the market's traffic controller. And every decision about visibility can create winners and losers. This is why digital platforms can become so economically powerful. They do not simply connect supply and demand. They increasingly determine how supply and demand find each other. The algorithm does not replace the market. It becomes part of the market's architecture. And the company that controls the architecture controls the flow. The most visible form of algorithmic power may be financial. Markets generate enormous amounts of information. Prices change, news arrives, risk shifts, demand moves, and capital responds. Humans can analyze information, but machines can process it continuously. An algorithm can monitor thousands of markets, track millions of signals, and execute decisions in fractions of a second. This creates a new form of competition, not human versus human, machine versus machine. The advantage may come from better data, better infrastructure, better models, better speed, and better predictions. The system does not need to understand the world like a human. It only needs to detect patterns, calculate probability, and execute the strategy. This changes the relationship between information and capital. A human may read the news, an algorithm may already have reacted. A human may recognize the trend, a system may have detected the pattern earlier. A human may decide to buy, a machine may already have executed the trade. Speed becomes a financial asset, but speed is only one advantage. The larger advantage is scale. An algorithm can monitor more information than any individual, and systems can operate continuously. This creates concentration. The most sophisticated financial infrastructure requires capital, compute, data, and talent. The barrier to entry rises, and as the systems become more complex, the advantage may concentrate among the institutions capable of building them. The financial market remains open, but the technological capability required to compete at the highest level becomes increasingly expensive. Some of the most important algorithmic decisions are not obvious. The system may not explicitly reject you, it may simply place you lower. A business may not be banned, its visibility may decline. A worker may not be rejected by a human, the application may never reach the final stage. A customer may not be denied service, the price may simply become higher. The system can influence outcomes without appearing to make a decision. This is algorithmic power in its most subtle form. The system filters, ranks, scores, and prioritizes. The user sees the result, but not always the process. This creates information asymmetry. The algorithm knows the rules. The user may not. The platform knows what it optimizes. The business may not. The system can change. The participants must adopt. This creates a new relationship between economic actors and computational platforms. A company may build its entire business around a ranking system. Then the ranking system changes. A creator may depend on recommendations. Then the recommendation system changes. A business may depend on search visibility. Then the algorithm changes. The rules are not always stable. And when one company controls the algorithm, the company can change the environment. This does not require malicious intent. The algorithm may simply be optimized for a different objective: engagement, revenue, risk, retention, efficiency. But every optimization creates consequences. The system rewards some behaviors, penalizes others, and gradually, participants adopt to the algorithm. The economy begins to optimize itself around the machine.
The most important feature of algorithmic economies is compounding. A company develops a better system. The system attracts more users. More users create more data. More data improves the system. The improved system creates better predictions. Better predictions improve the product. The better product attracts more users. The cycle continues. This is not ordinary growth. It is a feedback loop. And feedback loops can create concentration. A small advantage becomes a larger advantage. A larger advantage attracts more resources. More resources create better technology. Better technology creates more advantage. The system begins to pull away from competitors. This is why digital markets can become highly concentrated. The cost of serving one additional user can be relatively low, but the value of additional data can be significant. The platform grows, the algorithm improves, the network expands, and the competitive advantage compounds. Eventually, a challenger is no longer competing against a product. It is competing against years of accumulated data, infrastructure, users, capital, talent, and optimization. This is the algorithmic moat. It is not a wall. It is a system that becomes stronger through use. The more the system operates, the more it learns. The more it learns, the more valuable it becomes. And the more valuable it becomes, the more economic activity flows through it. This is how technology can transform a temporary advantage into structural concentration.
Algorithms may be digital, but intelligence requires physical infrastructure, processors, data centers, energy, cooling, networks, and specialized hardware. The more advanced the system, the more infrastructure it may require. This creates a new economic divide. Not every company can build the same computational capacity. Not every country can access the same hardware. Not every organization can train the same models. The cost of intelligence infrastructure can become enormous. And when the infrastructure is expensive, access becomes concentrated. A small number of companies may control the largest systems. Others may rent access. This creates a new relationship between intelligence and ownership. The company may use artificial intelligence, but it may not own the compute. It may use a model, but it may not control the underlying infrastructure. It may build an application, but the intelligence may come from another company. This creates layers of dependency, and the companies controlling the foundational layers may capture a disproportionate share of the value. This is a recurring pattern in technology. The visible product is built on invisible infrastructure. The application is visible, the data center is not. The interface is visible, the processor is not. The user sees the intelligence, the infrastructure owner sees the demand. And as more economic activity depends on computational systems, the infrastructure becomes more valuable. The algorithm is only the visible layer. The real economic power may exist beneath it. The algorithmic economy is not one system. It is a network of systems. One algorithm controls visibility. Another controls pricing. Another controls risk. Another controls capital allocation. Another controls logistics. Another controls access. Together, they create an invisible architecture, a system that determines how economic value moves. The algorithm may not own the factory, but it may determine which factory receives demand. It may not own the worker, but it may determine which worker receives opportunity. It may not own the capital, but it may determine where capital flows. It may not own the customer, but it may determine what the customer sees. This creates a new form of economic power, control without direct ownership. The system does not need to possess every asset. It only needs to control the decisions surrounding the asset. This is why algorithms are becoming central to wealth creation. They sit between supply and demand, between capital and opportunity, between information and attention, between the consumer and the product. The more important the decision, the more valuable the algorithm controlling it becomes. And as decisions become automated, the owners of the decision systems gain influence. This is the transition from ownership of assets to ownership of allocation. The company that controls allocation can influence the value of everything being allocated. And in a world where more decisions are made computationally, the architecture of the algorithm becomes part of the architecture of wealth.
The greatest economic transformation of the digital age may not be the creation of more data, more software, or more artificial intelligence. It may be the transfer of decision-making from people to systems, from organizations to algorithms, from individual judgment to computational architecture. This changes the structure of power because the person who makes the decision can influence the outcome, and the system that makes millions of decisions can influence the economy itself. Algorithms decide what receives attention, what receives capital, what receives access, what receives priority, and what becomes invisible. The system may not control every asset, but it can control the flow between assets, and control of the flow can become more valuable than ownership of the individual asset. This is the algorithmic concentration of wealth, a world where economic advantage compounds through data, compute, scale, networks, and feedback loops. The largest systems become more capable. More capable systems attract more users. More users create more data. More data improves the systems, and the cycle continues. The result is an economy where a small number of computational architectures can influence an enormous amount of economic activity. The visible economy remains diverse. Millions of companies, billions of consumers, countless products. But beneath the surface, the decision layer may become concentrated. A small number of systems decide what is visible, what is valuable, what is risky, what is accessible, and what is profitable. This is why the future of wealth will not be determined only by who owns land, factories, or financial assets. It will increasingly be determined by who owns the systems that decide how value moves. Because in the modern economy, the algorithm is not merely calculating the future, it is helping allocate it. And whoever controls the system that allocates opportunity may control the direction of wealth. The future does not belong only to those who possess the most assets. It may belong to those who control the systems that decide which assets become valuable, which businesses receive attention, which technologies receive capital, and which participants gain access to the next economy.
The algorithm is becoming a new layer of ownership. Not ownership of everything, but ownership of the decisions connecting everything. And when decision-making becomes infrastructure, infrastructure becomes power. Power becomes leverage, and leverage becomes wealth. Next, Sarah. Decoding systems, architecting wealth.